Hello everyone and welcome into yet another live stream, and today there I am. Okay, no one joined in yet, so we might as well just start with something simple, I suppose. Hold on, let me just turn off all my devices. There we go, not to waste any power. Yeah, no one's really joined in yet, so we might as well just start the render. I think it's fair, I'd say. Yup. Okay. So. Where was I in the render? I had the cube move over there, that makes sense. You can anything you want again, 5 pi, whatever. You can change them however you like. So there we go. Which means in this case, all we'd like to happen is probably just move the cube in some way, transform it. Alright. There we go. Still no one joined in, so might as well get to researching a bit. That's because, if you recall, in the past stream, we were trying to achieve some kind of connection between our machine. Oh, actually, no, this, I should probably leave this. Yeah, now I think about it, actually, meat and potatoes of this live stream would be probably would help with this some more. Well, I might as well just script. Alright. Believe it or not, is actually background required, which you ask the application before. Well, imagine a two-dimensional particle with the functional probability which looks like this. So basically, it's most likely to find particle in this in the middle, shrink again. If we bring up wall, however, then probability shifts. I mean, yeah, we bring in an impossible boundary right here. Obviously, we can't find the particle inside our wall. Instead, all of the probability shifts more to the left. Particle be found on the right. If, however, we keep moving our barrier, then it may be possible for some of our probability to leak. And once the probability leaks onto the other side, then some low as it may be to find the particle on the other side. Right. Now, the point I'm trying to accent in this case is that, first of all, it is just wild, because, well, you have a particle that just effectively happens to be on the other side of the wall. Second of all, that this is not teleportation or anything like that. It is just the probability of the particle moving through a wall, effectively. And third of all, despite it being wild, it is what actually happens, which is kind of why the theory of quantum mechanics, well, makes so much sense. Yeah, let's go for it. And you might think to yourself, hi Drum Holy Fingerball, how you doing? Hold on, I need a sip of coffee for this. My brain isn't thinking. Hydrash! Yellow indeed. Okay. This doesn't make any sense. How can our particle move through an impassable barrier? This would be teleportation. You must have gotten wrong. But no. Everything just thought. Quantum phase or quantum immortality, so true. What is quantum immortality? Is that a real thing? Can falsify any vertical mechanics other than the average minimum interpretation. The subjective experience of surviving quantum suicide. What? This didn't clear up anything. Wow, you never die, your soul or whatever goes to another universe where you didn't die. Oh, you mean that? But wait, hold on. Isn't like the whole another universe created for each possibility? Isn't that I'm sorry, my brain is thinking really slowly. Another sip of coffee make it? Isn't just one of possibilities? Wasn't that one of interpretation of quantum mechanics? Been good, been prototyping a circuit in multisim. Oh, what kind of circuit are you prototyping? See, our particle isn't moving through our impassable wall, nor is it teleporting. That's because it is just merely, oh, this is going to be idiotic, existing through existing through it. This is quantum tunneling, and basically probably either a new reality once they take over existing one. I think there's also an egg theory where everyone who has ever existed but reincarnated. I don't enjoy these theories much because they are always so grand that they are unprovable. To me, pondering these theories is... it shows to a certain kind... in my opinion, it shows to a certain kind of... oh, what would be the right word for it? What is... like an antonym of modesty. I don't know what... I'm struggling to find a word. Hold on, another sip of coffee will surely help. Pride? Yeah, pride is actually a very good one. Thank you so much, Ash. Yeah, pride. There we go. It shows to a certain kind of pride where, well, where basically you find you make a theory that is incredibly grand, so grand that we don't have a great way to prove it, but you still indulge it with a lot of thought as if you're assuming that you are correct. Like in physics, for example, when you're dealing with quantum mechanics or when you're dealing with string theory, when you're dealing with, you know, all of those very grand theories that are meant to describe all of physics, then experimenting on them is incredibly difficult because you have to deal with very small things most of the time, and you are looking for very minor things. And as such, that's why, you know, physicists always love their big rings. They always just need one more collider to solve all physics. And so when it comes to theories that are even grander than that, like questioning absolutely everything, I just don't see a great way to test them. And without tests, well, each theory is equally likely. The teleporting is just merely existing through it. Two things I want you to remember are: first, it is three things. Actually, I want you to remember. First of all, it is just something to test my knowledge of what I learned. I'm going to try to use a 555 timer as a PWM to connect to an inverter and create a quasi AC wave, and then use a cap to smooth it out. I see. Well, good luck then. People are just bored, like last Thursday or whatever. Universal last Thursday and everything from there is just fake memories and such. I mean, I suppose it is, but I don't know, it feels a bit egoistic, slightly, to indulge this whole thing. A bit much. That's what I'm gonna say. Because, as I mentioned, everything is possible, right? In science, you don't deal with what is possible, you deal with what's plausible. So when you think about a theory, you don't think of it in terms of is it possible, because that is a given. You think of it in terms of is it plausible. And when you have something this grand, how do you even check the plausibility? What do you measure it against? Like universe starting last Thursday or last Wednesday, how do you measure anything there? Like that would be the first step, wouldn't it? I just don't understand it. I'm basically everything it is the direct consequence. Hi, the Turfta. How you doing? Yeah. I knew that thinking you wouldn't help. I had to bring up philosophies and such. Hi there. Hold on. Let me turn back my lights and camera and action. Okay. You whoop. Oh, that's way too much. This is just right. Let me clean up my workstation a bit. Oh no, never mind. There, this seems to be in focus. Hi, the Tefta! I have a question for you. Or actually, more of a request, I suppose, because I would really like to know how to properly use Ryan. I really wish I had something to... I thought about it. It's very awkward, actually, because the camera's on the opposite side of the table from me, which means there isn't really a way for both me and you. Oh, hi, the Tefta.
Hey.
Yeah, I suppose I need to prop it up like this. This sort of thing.
I just lay it on his back, depending on how the AC cable is connected to it.
I suppose.
But yeah, you see, that's awesome.
Oh, there we go. And I actually thought of a good thing already.
Perfect.
I already thought of something that we could use it on that would be both useful and I think, in my opinion, would be... I don't know how to use an oscilloscope, so I don't know if it would be a great thing, but this, which is a USB module, and I do also have a USB cable connected to my computer. And at the same time, I am also trying to connect my Raspberry Pi Pico through a USB to my computer. So I feel like this is just a perfect match made in heaven.
Oh, heck yeah. That's awesome. Yeah, what I would do is first is connect the thing that you have to. You see how there's those three. I can't
Right.
remember what the connectors are called. CR something connectors. Yeah, but right at the end of it, there's two metal pieces. That's your signal. That's your signal generator.
Oh, so this is a signal generator.
Yeah, yeah, those two pieces of metal that are.
Right.
It's hard to describe. It's right here. Put it in the chat.
Okay, well, let me see.
Here's live voice chat, and here we go. It's this thing, and it doesn't want to send.
Oh right, ground. The one with the ground thing. So
Yeah,
this.
the ground is the ground, and the top is the signal. So that's the easiest way to get. Yep, exactly.
So do I just connect the probe?
Yep, ground to the ground, and then the red can connect to the top metal.
Right. Oh! There is in fact the signal.
Yeah, so you have it connected into number one. So number one is yellow, and the green one is channel 2. So directly, the whole column for channel 1, where you see it's connected, there's the big dial, and I think that's your x-axis, and then the other one is your y.
Okay.
Yeah. So there's you see the column where you have the third channel. That's your overarching view.
Okay.
So that's your yeah.
No.
Yep, right there.
No,
And
I
so
just
if
mean
you change
I'm sorry. I'm just operating it upside down, so it will take me. There will be a bit of a delay before I can actually figure out which part you're talking about. Do apologize.
but this is pretty much it. So this is kind of just understanding those 6 knobs are the most important.
Okay, so this is the. Uh, oh, I didn't mean to click it. Okay. Right. So this is the voltage then. Makes sense. This.
Yeah, that's the vertical axis. So what you're doing is you see the very edge of the screen, there's a yellow arrow. When you move that top knob or the knob that the small one,
Right. This.
it's you're moving the 0 line, if that
Oh.
makes sense. So you're actually adjusting where 0 is
Okay.
on that axis.
Okay, so I would like 0 in the middle, I suppose.
Yeah.
No.
So that way you can see it. Now so they're the overarching ones, which is the third column. That is going to define how big everything is, both the X and Y. And it's, yeah, those two.
Okay.
And that's your timing. So by increasing or decreasing that, you're seeing a bigger swatch of time. So you can zoom in time-wise. And the other one is left and right. So those are pretty much your controls.
Okay.
So that's like that's the first thing that you need to know. So those are the signal knobs. I don't even know what the proper names are.
In this case, I take it back, I suppose. Right here, I already have actually set up I2C. I suppose that would be.
Heck yeah.
I feel like that would be actually much better.
Yeah.
Yeah, so the Pico should already have the code for I2C on it. Get connected.
Awesome.
I'm so glad I installed the hold button. Would have been really awkward without it because it does have a boot file right now.
Oh yeah.
Anyone remember where I saved the files we're working on? I think I do know. Okay. Oh, if I actually manage to learn how to use an oscilloscope, this will be a mighty powerful tool.
It's out my oscilloscope, so I don't have to.
Okay, so right here. Hi the Megatechno YT. Hi, and hi the Goofiness. Hi, welcome. Okay, so we will have an. I imagine I2C. Let me just quickly try it. Let me first see if the I2C is working. For some reason, whenever I open the remote workspace, it just has to die on the first try. There we go. So, I'll keep the boot file as dangerous as this. Do you read the chat? Yes, I do. I'll keep the boot file as dangerous as this because I trust my holding button. At least for now, I trust my holding button. Then we're going to go into the we're going to go into the main, and we'll import the SSD 1306. Then we just create the I2C connection, we create the OLED device, we invert the OLED device because it always starts inverted, and then OLED fill 0, OLED show, and then OLED fill, no, not fill, text, and we will do testing. Actually, Ryan, why not? 0, OLED show. I don't know if you'll be able to see it. There we go, you can see. Tiny little text on the
Nice.
OLED. So yeah, so right now if I take out the... I don't even need to check which will be which because it will be clearly visible which was the clock. Right? So first things first, I need a second probe.
Yeah. And they gave you proper probes, I'm assuming, right?
Well, I mean, I also have right here this, which I'm assuming is also a probe because it has the same connector.
Yeah.
I don't know what the proper probe is.
So that's what I always use. So that's a probe. The other, that's what I consider a probe. The one with the two wires, the red and black, I usually don't use those.
Aren't the red and black easier when you just clap onto something?
They might be, yeah, but the probe actually, the tip has a little alligator clip that's pretty nice. So if you push down the tip, the whole tip sheath goes, and a little piece of metal
like a
pops up.
hook. Oh my goodness.
Yeah, and you can hook it onto things. So the ground wire is where you know, it's attached to the middle of the handle there. That's kind of free floating. So that's usually what I use when I do anything, is one of those probes.
Okay, so I will use... I only have one of the proper probes. I have two of the improper. It also has like a mode right here, like a switch that goes on one side. Says
1x or
yes.
10. So that's your levels. So by changing those amounts, it's going to change on the scope. And you usually want to tell the scope if you changed it from 1x to 10x, because in case you're reading a higher voltage, you would want to do that. Because the scope will also tell you the voltage amount as long as those two are matched.
Okay, well, I promised myself that I would go outside my comfort zone, and I do use the crocodile cables all the time, so let's try also using the proper. Okay, and then I imagine... Actually, I don't know if I'll be able to hook this in. Oh, shucks. I might need to actually switch to this.
Yeah, I usually just create two wires for myself. One with a really long end. You know, I just strip a solid core wire with both ends stripped. One with a little bit of a longer strip. And that's where I connect the probes to.
Average Bruce just said Tefta in almost all cap. Oh no, never mind. For a second I thought Average Bruce said Tefta and surprised to see you here. I was just asking. Yes, this is Tefta. Tefta, in the meantime, while I'm struggling with the cables, would you mind introducing yourself?
Yeah, I'm Tefta. I'm here. I have a YouTube channel where I do work on open muscle. I do some hardware stuff with making my own PCBs and trying to create an open source prosthetic sensor. It's my main project.
Yes, a lot of people really often mistakenly think that I am some kind of specialist in certain topics, which I am not. I am a generalist. I just surround myself with specialists in different topics, and Tefta is the specialist of electronics for me.
Sweet.
Yes. So basically, whenever I work on any kind of projects in the future, electronics related, all of my core knowledge came from Tefta. This is as a brief introduction if you'd like to know who Tefta is. Also, channel on YouTube, would recommend. I linked it in the most recent and second most recent video if I'm not mistaken. And I really love the emoji I added to the server. It's just... The
Oh, did
second,
you add it?
yeah, I did that. The second I saw it, it's the it works emoji, and the second I saw it in the short, I was like, yes, this facial expression. There was like so much behind it. It genuinely made my morning. It was incredible. But
That's
okay,
funny.
I have two channels now. I imagine red one of them connect to the clock, the other one to data. Doesn't matter which is which.
Yeah, and then both have to be connected to ground.
Yes, and both of them then connect to.
But you do want to connect the screen end. So you're only
Oh, I
gonna
see
see,
what you
right?
mean.
You're not gonna be able to, because the screen usually sends back its I2C address. So if you connect it this way, you will see the microcontroller communicate with um, those two wires, but it's just gonna stop real quick. So if you would want, what I do is if I want to see I2C in that case, I would constantly scan the I2C on the microcontroller, and then you can watch it, read it.
Hold on. So I will just for now. I'm going to use the yellow ones to create some kind of. Do you have any idea what he's doing? I am, in fact. This is my first time ever in my entire life using an oscilloscope. This is Ryan. Everyone say hi to Ryan because I obviously have a habit of naming every
Ryan.
single piece of equipment I own. Some people tell me that it's a sign of my that's a sign of insanity or whatever, but this is Ryan, and I'm really excited for this because a multimeter. This is basically a multimeter for electronics,
Yeah.
and I just the amount of times I've seen some kind of data of work with data, and I just wished I had a way to read it without relying on my code or on my hardware, which I am myself trying to test. Like you can't really troubleshoot a component with the component itself. I mean, you can, but it's a huge pain. So having a
Oh yeah.
separate dedicated device just for it. Okay, I think this should work then. Wait, in I2C, oh, I am showing my lack of understanding right already. In I2C, the SDA is is bidirectional.
Yep.
I genuinely
Duplex.
didn't know that. It makes sense considering how you need an address, but for some reason that thought never crossed my mind.
Yeah. Well, yeah, it's interesting because SPI, you have dedicated, like, what do they call it? No duplex or half duplex? I can't remember, one way. But yeah, it's only sending direction one way for each wire. But in I2C, they share the data line. So that's why you need an address. So yeah, that's funny.
Oh, and that
But
makes sense. That's why you can also all connect them all to a single network.
yeah, so you can, and you can connect 128 together on with one wire.
I really like that feature of I2C. It's because I imagine it eventually I will grow to love I2C for that precise reason. The fact that you don't need to bother with connecting everything different places. Not a single multiplexer, just every single device to a single wire.
Yeah, and usually you don't have to worry about speed, right? So I2C is a communication protocol where you you're not transferring large amounts of data, like, audio visual. You're just doing text or commands.
Okay, so I will guess that I need both of these lines. Well, I don't need, but it would be better to have both
Oh,
of them
so if you
aligned.
press in those buttons have like a push in. So push in on them and they reset to 0.
Oh, perfect. Okay.
And then also the bottom one is your voltage. So each of the squares on the oscilloscope is measured. So the bigger knobs for each channel, when you move those, you'll see at the bottom that there'll be a voltage symbol, and they'll tell you like 100 millivolts or 5
Right.
volts. That's telling you how big the squares are. So if you have it set to 1 volt,
try something.
then all the squares are 1 volt. So you can just count, oh, that's 3 volts up,
Oh, there we go. I should have done it at the very beginning. This is much better, isn't it? Because now on
Oh yeah,
stream
the
you can see.
contrast.
Yeah, okay. I should be should have done at the beginning. Okay, so
Oh, so yours is at the top, actually. So you have a different operating system, which is fine, but those big knobs still just adjust the voltage levels for each channel.
right, and I do want to keep it at volts so far.
I would keep it at like 1 volt because
Okay, 1 volt.
because you can see the 3 squares So 3 volts is be 3 squares high.
Okay, that makes sense. Now they are changing, but in very small ways. I imagine that's just noise so far,
Interesting.
or is it?
Yeah, can you zoom out? Actually, change it back to 5 volts.
Oh,
Because I don't.
I just did the OLED.
Yeah, so that's okay, good. So that's working. So it doesn't send information unless something's updating. And if you reboot the device, what you'll do is you'll be able to see that happen. So another thing that the oscilloscope is pretty important is the trigger. It's the knob right by the green glowing button on the
This
corner.
level trigger. Or trigger
And
level.
when you move that, you should see a dotted line move. Yeah.
Oh, I see it. Yep.
And that will, if you put it in between 0 and 3 volts,
Like how?
what the trigger does is it says, hey, if a signal comes in and crosses this threshold, then pause.
Oh, makes sense. Okay.
So if you're looking at a waveform and you want to automatically zoom in, now you're getting to the end of my knowledge on oscilloscopes. So this is about it. If you press that green button, it will stop recording and it will just keep the information on the screen. That's your start and stop. So then you can zoom in and look at a waveform. So there's a way to trigger it so it automatically stops once it sees a signal, but I'm not sure how to do that on this one.
Okay. Already makes sense far. If I now try to connect to the screen, then I2C isn't. Wait. Oh, wait. What? From machine import pin. We've okay. Bit of a pickle. There we go. Now if I try to connect, the yellow line disappeared.
You might be, it moved up a little bit. You might need to press in the knob again.
Oh, I see.
Because, although, never mind,
No.
it doesn't matter.
Oh, wait. Hold on.
The small one.
Okay, yeah, they are both at the top. Right. So now, wait, hold on. If I do OLED, wait, OLED device like this, and if I, what do you mean that isn't defined? Import SSD 1306.
Yeah, it might not even communicate until you do like an I2C.scan.
I just did that.
Oh, weird.
Oh, no, that's, hold on. I can do this time again, and then I can try it yet again. No, it just says that the function isn't defined. What happened? It very much should be.
Interesting.
Yeah, it is right here. Oh no, why am I... Damn it! Of all the times that this could have possibly happened, obviously this happens the one time I actually don't care about the Python code. The specific reason why I set all of this up was that I wouldn't have to deal with it when times come to it. Okay, import SSD 1306. That should import this precise file right here, inside of which there is the SSD 1306 I2C connection defined. I mean, worst case scenario, we can just do I2C ourselves, I suppose. Like manually.
Yeah.
I don't know what the manual commands for I2C are exactly.
Oh, just, yeah,
Right.
I2C.scan.
Okay, so
If you have a variable that already has the pins for I2C defined, just do whatever that variable dot scan in
Yep.
the open close bracket.
it did. It shows address 60.
But yeah, but you see it flashed on the oscilloscope.
The camera can capture it every single time. It's actually it's. Hold on, can I? Okay, so the trigger. If I want to trigger it on the scan.
Yeah. So this is where I always forget this. I think it's what you do is you press auto set. I think it's the button right by, yeah, right there. But that's when the signal is coming. And that will automatically try to see the signal and set to it. But I'm not sure. Actually, I don't even know.
Okay, so
I think you can click on single sequence, the other button too. Those two white buttons by the green button, they probably work. I'm super helpful, aren't I?
I feel
Yes,
like I don't know.
there's a cheat code.
I feel like I'm flying a plane. I mean, not flying a plane, only like a passenger on the plane, and the pilot just passed out, and I'm just there in the cockpit looking. I'm also operating it upside down, which isn't helping. Where's my manual? I have the manual somewhere down here. I know it for a fact because
Let me look it up. And what's the model of that hand tech?
this is good question. Handtech DSO 2D15. DSO 2D15.
Perfect. I'm gonna look that up.
I mean, I'll be brutally honest. I wasn't expecting you to, know everything about my oscilloscope. You are already being unbelievably helpful simply because.
But it's super, like, one of the most important things, and this is something I haven't learned to do, and I have to look it up each time, but is to trigger your oscilloscope. So there's an actual third column. You see how there's a third probe on your oscilloscope?
Yep.
That's meant for a trigger. So you can set up like a hardware trigger, like a one pin
Oh,
sends from the Raspberry Pi, and that will trigger the oscilloscope to stop there. So you could encode, like, tell it to stop. Isn't that kind of cool?
that
So
is really useful.
yeah, and so I don't use this feature very often, but it is a very important feature, and I'm all self-taught, so I don't specifically know.
It's fine. Hold on. I have.
But
No, that's the wrong user manual. That's the user manual for my CNC machine. Um, I unpackaged all of my machinery, and so I just have all of these boxes with all the things for all the stuff. I think I have a. That's a quality certificate. That's not helpful. I trust you with quality. I bought the machine. Worst case scenario, I'll need to just rewind the stream and see where I put the manual. Oh, I have the warranty. That's good to know. Don't care about it right now.
I have the manual, and then I'm asking AI.
Oh, you found the manual.
Yes.
Kind of funny that you found the manual faster than me when I'm looking for a real physical manual, isn't it?
Yeah.
I vaguely remember having a manual, but well, it would make sense to have a manual that comes with the oscilloscope. But oh, and my camera just died.
Oh no. Trigger type.
Okay, hold on. I need to. I'll be right back. I need to replace the battery for my camera.
Oh, sweet. So it looks like a menu pops up, at least on mine, when you press that auto set button or the single sequence button. And then you can change what type you want to see. That's kind of cool.
Okay, I'm back. I heard you say a menu pops up.
Yeah, so you set the trigger correctly. So if you press those two buttons, one of them is auto set next to the run stop button, and then the green button that's lit up. And the other one is single sequence. I think if you press the single sequence or the auto set, mostly single sequence, you can change what type of signal you're looking for. And so those function buttons, what does it say there? I can't read it.
It says can't. Oh, it just turned off. Hold on. It says source only display cancel.
Okay. You can press F4. So those F buttons are like buttons since the
Right,
screen
makes
isn't
sense.
touch. Yeah.
Source all.
Yeah, that works.
Okay. Question
And
is,
if you yeah, so if you run a signal through it, it should stop. So if you do I2C scan from the board.
right? Um,
And no, well, because it's not a continuous signal. Yeah. I don't. So yours is stupid. Yours is stupid. Because if I press my single sequence, it will literally just stop when a signal crosses that threshold.
oh, maybe I just have to do it like this.
Yeah.
Okay, I think I think I'm really close to using it properly, but not quite. So like this. Okay, it
Then send it.
should be. It gives me up. Okay, so wait, in the middle there is a signal right there.
Yeah.
Oh my
So
goodness.
there you go. So you this is how, yeah, it's triggered and it's stopped and it saw it. So you can zoom in now. Those two big knobs on the third column, now you should be able to zoom in, and since it's paused on the screen.
The two big ones on the.
Oh, the one all the way. Yeah, there you go. Those ones.
Oh no, the chat changed voltage. Right, so this.
Yeah, so you see how the segment doesn't go all the way to
Okay.
the edges?
Oh, there we go. I feel like, I don't know if you get the reference specifically, but I feel like just a mechanicum cultist who has an archaic piece of technology. I never remember. You're not really into Warhammer, are you?
No, but I've seen a couple of
Yeah.
shorts on Netflix
Basically,
about it.
yeah. Basically, there's like Cult Mechanicum where they don't do science. They don't like inventing new machines is forbidden. However, they do find old pieces of machinery, and then they cannot reverse engineer how they work. So instead, what they do is they have long set of rules of what to do in order to get the machine to do something, and that's what I feel like right now because I did just get that to stop right when the signal happened, but I have no clue how. And every single time,
Yeah.
and I'll just need to click the 7 combinations of buttons because
But
this makes sense.
The bottom one, or to you, it's the top one, where it says single sequence. If you press that and then send a signal, it should just stop. The auto set, I think what it does is it tries to automatically zoom in based off of this signal.
Oh, so the signal sequence, that's it. Okay, so if I
That
do
should be
run
it.
right now, and if I do this, and if I
Yeah.
run a scan, oh my goodness! Witchcraft, sorcery.
Yeah. So the auto set just automatically shrinks it or makes it bigger. But that, so now you're able to see when that when it comes by and look at the waveform.
Oh, beautiful! Absolutely beautiful. Hold on, let me just. I just want to try it again. Oh wait, twice. Why twice?
Why twice what?
Is it the response from the display?
Yeah, if you zoom out, you might be able to see more.
Oh, it makes sense, and I need to zoom out fully because it only does the signal sequence on the amount I've zoomed out. Oh, I didn't.
That's correct. And there's only a limited amount of memory on these oscilloscopes, and there's a lot of data flying in that screen, right? So when this goes on, it's pretty impressive it can capture all this.
It really is. Hold on. Let me just zoom out. I keep forgetting to prime it.
So by you doing this, I now know how to do it myself. I'm honest, I kind of do the thing where I have this weird set of rules and press the buttons until
Yeah,
it works.
exactly. That's what I'm saying.
If I'm gonna be honest.
This is good. This is really, really good. Okay. This is curious though, because there's no signal, and then it sends, it starts, and it keeps going. So, oh, I can move it as well. Oh, this is incredible.
Yeah. So it's sending a lot of data. So there's going to be like, hey, I exist. Is anything there? Maybe some information back. And then it will be dead silent. Right? It probably all happens in like a tenth of a second. But so you now actually can measure the length and the frequency of all these things because all that information is at your disposal.
I love just how much noise there is in this, by the way. Like I've never seen a better display of just how shite my connections are. This is
Yeah. Well, and this is for data integrity of signals. It's interesting to see why a missing capacitor might make a communication program, a protocol, really
I would
go slow.
I would love to connect the oscilloscope in between the LED pins when I actually have the band. Connect the
Yeah.
oscilloscope in between the data of the LED pins to compare with the coupling capacitors versus without.
And you should be able to, because you have a gigasamples per second, which is I think you have 150 megahertz oscilloscope. You should be able to see a lot as long as it's not a higher frequency than that. So that's your only limitation.
I do have a question though, because I don't know if this is just me not understanding I2C. If I zoom out completely, then right here there was nothing, and then when I did the scan, the data just kept going. Is that really how a scan on I2C works? It just keeps scanning for that long.
Well, how long is that?
Well,
What's
that
the
is
time domain?
um
When you adjust the knob to zoom in and zoom out, there should be text somewhere on the screen that changes,
oh
and it will tell
I
you the
can
width of each.
I mean I can also move the face and see how far I need to. So it's because it is in milliseconds. This is it goes on
Well, it's
for
sub-milliseconds.
what?
So move the zoom one in and out, where you can zoom in and out, and that will tell you the width of each of those squares,
Okay, so
whatever the
right now
text
a
is
square is
changed.
a millisecond.
Okay, perfect. So 1 millisecond, so then you can actually just calculate by counting the squares.
Let me move it to something more yieldy. One,
But it's
two,
not like
three, four,
20
five,
milliseconds.
6, 7. It's like 7 milliseconds.
Yeah, 7 milliseconds. That's very quick. So you can't even notice that with your ear.
I mean, I know it's
Like
quick, but like,
32 milliseconds is a
oh
delay.
no, no. What doesn't make sense to me is that really how long an I2C? Because for like a standard of sending data, that would be pretty slow. Well, not slow. Actually, no, no. Slow is not the right word I'm looking for. It just would be a long time.
Yeah, I mean, a lot goes on at the beginning when you boot it up. If you leave, so what you should do is clear this out in the screen and just read. Let the device boot up, but then just update the screen and see how much information goes with just an update.
You know what? There's a splendid idea. So let's do OLED. Oh yeah, I forgot.
Oh, darn.
Reset, and I expect you on your correct behavior this time. In phone machine.
Or you can just do an I2C scan again after the boot process. Or is that what you were doing for the
Yeah,
last
yeah,
signal?
I was scanning.
Uh, oh, wow. Usually the scan is very short. It's like a blip. I don't know why yours is repeating that many times.
That's what I'm saying, right? That's precisely the question I had. Like, why would the scan
Yeah.
go last for milliseconds? That's why like the long time didn't make sense.
No, you should only see like about, I don't know, less than 60 bits of information.
Exactly. Yeah. So that's what confused me. That didn't make sense to me for a scan on I2C to go on for milliseconds. That is an incredibly long time. I should have probably specified. I think you can move the trigger point on it to display more of it. I mean, no, I don't need to display more in this case. In this case, it's more like I'm not. This is not a question about the oscilloscope at this point. This is just like I'm curious what kind of data was being sent.
Yeah.
Okay, so let me just set up the dev, and now we can actually see how in this case I know what my problem was. No idea who was loading them in previously. Pixres, obviously Pixres is defined. Oh, so I was just importing main. That makes sense, 128. I don't know why I was importing main, but that makes sense, 64. Okay, even more problems. Can I just do import main? Not.
Yeah, there's only 32 pixels. It's 128 by 32.
Oh, but is that the problem here? That was the problem. Egg on my face. Okay. Now what I can do is I can just write a simple command to the OLED. like this. Oh, there we go.
Yeah. So not much information there.
Yeah, and if we zoom in, we can actually, like, we could reverse engineer it, couldn't we?
Yep, you can.
Another interesting thing. Oh, it makes sense. It really makes a lot of sense. I just never thought about it. But yeah, the clock only activates for the data. If there is
Yeah.
no data, then there is no clock. That's curious.
Yeah. It's almost like a trigger.
Let's try to, just for funsies. I am a child right now who's excited about their new toy. I want to try
That's
to
awesome.
read it because
I'm so happy you have one because there's so many times
yeah,
where
you've been
it
trying
it
to,
will help you.
yeah, you've been trying to convince me to get an oscilloscope for years at this point.
Yeah.
My goodness, I finally got around to it. All I needed was a shopping spree.
That's awesome.
Okay, it is.
But so many times when you're working on something, like we would be able to find what was broken. Or if you had a bad solder joint, this is a good I2C signal, not too much noise. Anything more than this,
Yeah, exactly.
it's probably going to have errors.
Like-
and then it's your solder, not the software.
So far, the multiple points of failure. Hi, Decatsi, by the way. The multiple points of failure is what I always mention as the most difficult process of engineering, and this one takes care of basically anything signal related, which is a lot. Because
Yeah.
at this point, if I have device A, device B, connect them together, they don't communicate, then at this point, faulty, I can basically rule out any connection related problems with an oscilloscope. If
Yeah.
I
Is
had
it
this-
actually sending data?
Exactly. If I had,
Now you can tell.
if I had this when I was dealing with UART, then I could just plug this bad boy to a Raspberry Pi Zero directly on the pins and just see what the Raspberry Pi Zero was doing. What's more, my Raspberry Pi Zero, when I connected to the Pico, and if I scan it on I2C, the scan took a really, really long time. And right here, I could actually figure out what was happening during that time.
Yeah, I'm guessing the code was running too many times because I've done that only when I've put the I2C scan within a loop.
I mean,
That's the only time I've seen that long of a signal before.
you mean in this case?
Yeah.
Oh, I was talking about when on the Zero, when I connect
Oh.
together a Pico to a Zero through an I2C connection, then on the Zero there's like a dedicated program to scanning I2C, like a operating system dedicated program. And whenever I scanned it, the program would would take a really long time. And in this case, I would be able to see what was happening.
Yeah.
This is it feels incredible. I can send text. I want to see text. I want to see text.
Encoded text.
I want to see what's going to happen if I do text Ryan and then 00, and if I do this, and if I do this, and if I do... It did not trigger. Oh, that's worrying. Uh-oh. Okay.
Well, where's your trigger line at?
My trigger line is at... Maybe between this and the clock, shouldn't it? It's on... hold on, I'm trying to read
should work.
backwards. It's on 0 volts right now. Well, that could be the problem. Let's put it at 1.2.
There you go. Halfway in the center.
I mean, worst case scenario, I just need to run the command with my left hand and then click the stop button before the signal moves, right? Should be easy.
Yeah. I've done the past. Seriously, when I forgot how to use the trigger. It should work though. The trigger should work flawlessly.
Oh, because this is the trigger.
Yeah, that's the trigger.
Okay, so... Oh, it's a single grid. Wait, why is the...
So it looks like both of the, you see those two arrows. You see a green arrow and a yellow arrow at the very edge. You might want to put those both at 0. Yeah, there you go. Then adjust the trigger value.
9 volts? Wait, what? Oh, because I
You might.
messed up. I no, they were unequal. No, that makes sense. Which means like this.
Yeah.
There we go. Yeah, that makes a lot of sense. Let's put the trigger like 1.5, and let's try it. It's curious because both of the lines are on the same height right now. Why stop
They
it?
should be.
Oh,
They should
they
be.
should be. Okay, but
If they're both zeroed out.
wait, that is 0. 0 is this
No,
high.
the middle line is 0.
So they are both at around 3 volts right now.
Yeah, so they're both getting 3 volts of electricity. That makes sense. And so they'll dip down to 0.
Oh, they dipped to okay. So I need to go right here. But then
Yeah.
if I
And it should cross that threshold. I mean,
okay, so
it's pretty interesting.
I'm going to set it up now, and if I run the text, oh, maybe it's just not getting any text because it already got the text. Maybe that's the problem.
Yeah, it might not have a
Okay,
change.
yeah. So this is the show then.
There we go. Yeah, because the code didn't have to send the signal yet.
Right, that makes sense. That does certainly make sense. So I show, and then we restart. If I set up the sequence, if I once again, it's not detecting the text.
But does the text show up on the screen?
Yeah,
the screen's still blank.
it says Ryan right now.
Well, yeah, but now a signal's on the oscilloscope.
Yeah, but it only got the signal for the show.
Try it again. Try it again. I think the screen was blank before you hit show.
Yeah, okay. So right now the screen is blank. I turned it off.
Oh, I'm also
Then-
watching a delay.
Oh, I can. Oh, I can't. Never mind. I was about to say
that's
that
fine.
I can give you a
fine.
stream, but I cannot. Okay, so right now the screen is off. Then what I do is I restart the oscilloscope. So the oscilloscope is running. I prepare the command for
Great.
text. I do signal sequence. So now it's waiting. I run the text, and nothing is happening on the oscilloscope. So
But what about the screen? Is the screen show the text?
no, it is. Oh, so you think that? Oh, I get what you
Right?
mean.
So the screen
Oh,
doesn't-
I'm an
The
idiot.
screen doesn't have it.
Right.
Yeah, there you go.
So this.
Now it's sending the information because it doesn't send the bits until there's an update.
So OLED show command is the. So everything that happens pre OLED show command happens only on the Pico,
yeah,
and that is just
until you
preparing the
update
statement.
screen.
I see. That's curious. I didn't know that's how it worked. Because I've never had the opportunity to actually measure it. Which means right now, what we can do is we can actually zoom in on this, and then we can
Reverse engineer Ryan.
reverse engineer
But
the text.
It's just the pixels of Ryan because those are probably just pixel locations on the screen.
Exactly.
And there's probably like hey, flip these bits or something, and then these are the specific ones to flip, and then update.
Oh, that is great. That is absolutely phenomenal. The power. What do I do with it?
Measure the speed of light. That's like the first thing I tried to do. That's an insanely hard project. I don't recommend it. I was just being facetious.
I'm not going. I'll be brutally honest with you. I am not going to measure the speed of light.
But you can. The fact that you can with that instrument.
Oh, it's
That's how
honestly.
powerful those are.
I don't. I mean, yeah. I guess at this point we just do useful stuff. Enough screwing around. We're going for broke.
There you go.
And in this case, I am going to use the other probe because I feel like it would be much better. Oh, if I only figure out how to disconnect this one.
Yeah, those are like push and twist. They lock in. There's 2 pins that lock in to those. And you want to be very gentle with those because your probes are the only way that it can accurately measure the voltage is if those probes are in pristine condition. So that's why a lot of people there's also a little screw on that bigger probe that you can adjust to even fine tune it. Those bigger probes. Not that you should do that. I'm just letting you know.
Okay, so these go right here.
but you can buy like $200 probes. It's possible to purchase probes that are more expensive than oscilloscopes.
I mean, I suppose it does make sense, but I imagine you need a pretty powerful oscilloscope to have a need for that kind of probe.
Oh yeah, like, high frequency, super
Yeah.
crazy. But if you think about it, those connections are a point of failure. So they have to design this instrument in such a way that the connection is as solid as possible. It's kind of interesting engineering.
Two things. First of all, in all of my time, whenever I do anything with clocks data and such, I always use the color green to represent the clock and the color yellow to represent the data, the signal.
Oh my, it's the
And
opposite of what I do.
and well, it's the opposite of what you do, and it is also the opposite of what I did right now with the probes. You can't see it, but right now the probe that I'll be using for signal is actually in the green one. It's what I always do, because yellow is always the like when you have red, black, yellow, then red is the voltage, black is the ground, yellow is signal, and so when I just added the clock to it, then the only other cables you normally get are the green ones. So that's why I just went for green.
That's funny. For some reason, I think clocks are more yellow than anything else. That's the only reason I picked yellow to be my clock signal.
There is no justification at the end of the day. It's just the standard I always go with, and I just think it's funny that with that standard, I right now did the exact opposite to confuse myself. Okay, so on the module, I am getting ground V bus, D minus, D plus. Ground V bus are obvious. The question remains, which one, D plus, D minus, which is which? Because
Yeah, so those are your two data lines. RX and TX.
because the D minus could either mean, well, D plus could either mean sending data there or sending data from there. I don't know if you get what I mean. Like D plus could either mean that's where the device is sending data from. I suppose that's what D plus would be, probably, right?
Yeah, so RX is the receive and TX is transmit.
Unfortunately, there is only D plus and D minus, which is...
Well, those are, yeah. And oh yeah, so what is D plus?
That's exactly the problem.
Got it. I'm daft sometimes.
No, it's fine. It is absolutely...
They're not in the same way. Okay, the signal method, they carry it simultaneously. It compares the two between them. Wow.
USB D plus D minus. High frequency USB signals. Oh, they are well, I still should be able to measure them. By the way, they are apparently different from the UART.
Yeah, they are. That's what I was seeing too. So they're just custom to USB. But what's interesting is you do have to have those resistors set to them.
Okay, unplug.
They usually work just fine. So you shouldn't mess anything up by probing it.
All right, trust you.
Yeah, you won't mess anything up, but it could be that it can't detect it. So you might want to do the same thing like you did with the screen and connect it to something.
Well, that's the problem, because I don't think I have anything to connect it to.
Yeah.
That's a pickle. I somewhere in the back of my mind vaguely remember having another USB module that this time had an...
Do you have... So you almost want resistors too, because I know if you put those two resistors on D plus and D minus, I think it's a 5.1 kilo ohm. I'll look at my schematic.
I just am looking through my cupboard of all of the different components, and every single one of them I can just measure with an oscilloscope. Yeah. Like this, for example, I can reverse engineer. I can also read about it online, which would be much more efficient. But I can reverse engineer how to use this board for the stepper motor.
You should definitely look at that signal. That would be a really cool signal to look at.
There's so much.
So yeah, 5.1 kilo ohm resistors on... Oh, I don't actually have those on D plus and D minus. Those are actually on C1 and 2. Never mind. Those are probably on that board already. I've never tried to read a USB connection, but you'd probably want to do like a middle attack that it's communicating with something.
Yeah, I mean, I imagine with any kind of connection you prefer to do that. Probably.
Unless we look up what we need to do to those pins, because maybe we need to pull them low or pull them high for some reason to trigger some kind of response from the computer. But we'd almost have to reverse engineer the USB
Yeah, I mean,
protocol.
ideally we would probably, ideally we prefer probably like actually setting up some kind of normal connection with something and then only measuring that connection.
Yeah, that or a UART connection,
Can you
like
do
USB to UART, you could read the output of that.
I'm trying to think if I can fashion up a UART connection somehow. I vaguely remember having another USB module which had UART on it. I just need to find the USB module. Oh,
Yeah.
what is that board all about? I don't even know what this board is. I just have it. Hold on, I have so many unopened modules and boards because, well, I'm a shopaholic, and whenever I buy something, I always buy extra just to get the free delivery, and so I just end up with this. Looks almost like a proper microphone.
It probably is.
It might be. Why I like remember the idiotic tiny blue one. I shouldn't be so
Do
negative.
you have a speaker? Do you have a speaker anywhere?
Do I ever?
Plug the
Absolutely.
speaker directly to the oscilloscope. Like, speakers are also microphones. So you can literally see the waveform.
I mean,
Yeah.
I also have a microphone.
But the speaker is better because when
Okay.
you literally can that's the raw signal. That's super cool. That or a motor. If you plug a motor and spin it, you can see the output.
Okay, hold on, because I should plug in one side of the speaker. Wait, do I just plug them
It
in
doesn't matter. Yeah, they don't matter for polarity.
Oh, I feel some kind of witchcraft with plugging the other side into the ground on this, but in retrospect, yeah, it does make sense.
Well, it's AC signal, so
Okay,
it doesn't matter because it's going to go up and down. It's going to produce electricity and not. And so when you tap on the speaker, you'll see it on the oscilloscope.
it is.
You might have to zoom in. You might have to make the voltage zoom the y-axis. So that way it's like small. Yeah, and then tap on it.
Oh, it did move.
Yeah. But a motor is
Motor
going to be
might
the
be better.
strongest signal.
Especially since I have a motor which definitely will be a stronger signal.
Yeah. And you just spin it by your hand and you'll see the crazy waveform. And you also see all the noise from it. Don't spin it too fast and you'll want to zoom out.
Okay.
Because that will generate easy 3 volts, 10 volts maybe even. Yeah, you have to zoom way out in time. So zoom out time-wise, so that way the thing across the screen is super slow. And that will be the last column.
Okay.
The other way, you're zooming in. If you want to zoom out, so that way
I didn't realize. Yeah. Okay. I 5 microseconds. Okay. 20.
Yeah, zoom all the way out till it's so slow.
Oh,
Yeah.
oh, this is incredible. Hold on. Okay, okay. Not quite. I feel like it's getting it at the front.
And so yeah, and the reason being is it's looking for a sequence of things. You'd have to spin it fast, so that trigger may not work. But zoom out even further. Like seriously, zoom out as far as you can, time-wise.
Okay, so well,
Keep zooming. So it's so slow that it draws across the screen.
okay, 2 seconds might be a bit.
Yeah. So that way it takes like 3 seconds to
Let me
traverse.
just. How about half a second?
Oh wow. It should be going across the whole screen.
This is witchcraft.
There you go. There you go.
Oh, it left my screen.
Yeah. So it saw the signal and stopped. Yeah,
Oh, this
I don't
is
know why it's stopping.
this feels wild. Okay.
Yeah,
Oh, this feels like witchcraft. I
but
just
it's crazy to see those waveforms. And you talked about making a motor controller. So a motor controller, you would use an oscilloscope to measure the output. And sometimes those are three phase, so you only have two channels, but they don't sell three channel oscilloscopes that I've seen. It's usually only two or four or one. Oh, look at that signal. That's crazy.
this is
Huh.
wild. Okay, so I believe he's playing around Disney possibilities. I am in fact learning how to use an oscilloscope, and I feel like I could actually use one by now. This one will be fun. I really want to test this one. This is my field detector.
Oh.
Yeah.
Oh yeah, and it has an analog output. Any analog sensor.
Exactly.
Yeah,
Like I'm
heck
just,
yeah.
I'm just looking through stuff. We can use this, which is a loudness detector. We can use this, which is a microphone. We can use another one I've
Oh
had
yeah.
lying around. I don't know exactly where it is, but I had an infrared detector, which infrared detector would be so much better. Oh, where is it?
Well, yeah.
Oh, I feel like a kid that's been let loose in a candy store. All right, with my infrared detector.
So many science experiments now.
So many.
Because like one of the things is an LED is also a photocell, right? So you can see electricity being generated by just plugging in an LED to your oscilloscope. By shining a bright light at it, it will increase voltage and generate electricity.
Quick question. If I have an analog measuring device, 3 pins, voltage,
Yeah, you want to
signal,
power
ground.
it. Yeah.
How do I power it without wrecking
Yeah, so
everything up?
you'll want to, of course, clip ground and power to the 2 pins, but you'll also clip the ground of the probe to the ground. And then the signal will just be the signal to the oscilloscope. So you have to have a power supply to power that.
Okay, got it. Got it. Wait, so
But you can always use
ground to the signal. Like ground of
Yeah.
the oscilloscope to the signal of the device.
No, ground to ground on the 3 pins. So you're going to be, so 2 wires are connected to the power supply, but the ground of the probe of the oscilloscope will also be connected to the ground of the power supply.
Hold on.
And then you put the signal on the signal line.
Hold on.
Does that make sense?
I mean, hold on. Let me maybe draw it out because that'll be
Yeah,
that's probably much easier then. So there is the measuring device, there is the power supply, and then there's the oscilloscope. The oscilloscope has voltage ground. The power supply has voltage ground, and then the device has voltage ground signal. And so obviously, so this will be the powering. Hold on, this will be the
Yeah, so the power supply
device,
and the probe
oscilloscope.
ground are both connected to the ground of the 3-pin component.
Okay, so all the
So
grounds
the light
come
cables
together.
are all connected.
So all the grounds come together.
Yeah,
Then
like that.
power of the powering device to the power of the this,
Yep, exactly.
and then
And then the red to yellow for the, because you'll signal line from the oscilloscope
okay,
will go to the
that
signal.
makes sense then.
Yep, that's the proper setup.
The enthusiasm in your voice at that moment is genuinely heartwarming. You don't want to start creeping anything. Oh no! Please do go ahead. This is it is. I mean, I am really excited for it. This is a incredible piece of machinery.
Yeah, it's insane. Like you can measure every it's so weird. And like when you have these analog sensors and an oscilloscope, it's like a really high sample rate ADC. But every data that we collect is based off of what you're seeing on the oscilloscope. Like everything is a Fourier transform, an AC signal converted to, digital signal, ones and zeros. So you literally are looking at like the data,
That's
the input device for all of science. Like everything comes down to oscilloscope. You want to measure weight? Oscilloscope. Like
hold on. I'm getting a personal. I'm doing it. I could also get my proper power supply, but it's banished on the outside, still from my... I shouldn't be dropping things on this board, because I'm pretty certain it's a... I'll have to look into what that board actually is, because I don't know if it's a microphone. It might have one too many pins to be a microphone.
Yeah.
It has... Actually, let me just... Maybe you'd know just for the pins. VCC ground, SCL, SDA, XDA, XCL. So SCL, SDA, just like I2C, but also the same one with X. And then ADO.
It's probably the in and out. My guess is that you put it in a chain of other sensors.
Oh,
so they just
that
give
would-
you another pin to continue the 2 signals for I2C.
That would make sense. I just need to grab myself another... A while back ago, I was buying stuff from like a bulk seller of electronics and electronic components, and I bought like 20 or 10 of just these cases for batteries, and it's just one of the best investments I made. The amount of times you have a lot of batteries, but you need a simple power supply, and now you can just cram them all in like this. Get some cables. There we go. Red, yellow. Should I test the microphone? Let's test the microphone for now. Okay, so power to power. So power to. It says V 5 volts, so I'm pretty certain it'll be fine with 6. Ground to ground to ground, which means on this one, yeah, it lights up.
Yeah. You're not going to damage anything because the oscilloscope can handle that voltage. And you will want to look at the manual. You wouldn't want to put something too high of amperage on it, but
Squeezing in the last pin is going to be.
this is where that probe tip might be handy.
I don't want to damage it. I only have one. I am very wary of using it. Okay. Now the question remains.
So you see the signal, it's pretty high voltage. It's 6 at the top. Yeah, that's cool.
All right, let's bring it both to the same level, like 200.
That you might want to zoom in because time-wise.
Yeah, so it is sometimes detecting. There is, I imagine my connections must be so terrible that it's just doing much. Okay. Now another thing I can do is this oscilloscope, not oscilloscope, this microphone has a potentiometer which can be actually adjusted. Okay, do this.
I was just kidding, by the way. I typed in chat that I'm not turfed, but I am. I said I'm not the guy on stream.
It would be funny if the guy in chat actually said, "No, I'm not."
Yeah.
Full argument. Okay, if I screw this way, it is not really. This is actually really tricky because okay, so I found this way it's very sensitive, which means right now.
Oh, that's the threshold. So you're setting the threshold
Yes.
for that. It's getting a digital signal output from an analog input. So it's like a threshold device.
Let me just 2 seconds to see if. I don't know. Yeah, I feel like my pin connections are the thing that are. Okay. Wait, hold on. Why is this yellow? This worries me. Why are you yellow? Don't be yellow.
It's waiting for a signal,
Okay.
I think.
So now, if I just speak into it, then we are getting signal.
Yeah.
Which means that.
Oh, it stops once it hits the end. It's based off of your time, so that's why it's yellow. It's waiting for the full signal, the full screen to refresh, then it pauses.
Okay. But I don't want it to. I wanted to just keep drawing.
Yeah, it's green, so it shouldn't do anything. It
Okay.
should just continue to draw indefinitely.
Oh, the pin is. Okay. Test. Go on. Yeah, my setup is a bit shabby, so won't hold it against it. This is great.
And that's also a digital output device. Analog ones are cool. Like an LED. Like seeing that an LED based off of brightness actually produces voltage is interesting. I didn't know that till I had an oscilloscope.
I just happen to have an LED on hand. Okay. One and oh shucks. Okay, plugging this in will be tricky.
This is why you can modulate a laser. Put the the power supply for a laser, modulate it with an actual from like an amplified microphone, and it will send it over laser, hit an LED, and you can plug in the LED to a speaker and it will play.
I'm modifying the wrong thing.
Yeah, you might have to zoom in both in time and voltage.
We are on 2 milliwatts right now.
Where's the? Is it drawing across the screen? It looks stopped.
Yeah, this stopped, but can I somehow disable it waiting for a signal? Can I just tell it to just keep on drawing?
Turn it on and off.
Whoa! That's a lot of voltage, alright. Oh, now it's not. No. I didn't mean it. It's not changing. Oh, nothing. Okay, well.
It's still on yellow, yeah. It's still trying to trigger. You might just be in. Yeah. What in the heck? Why isn't it showing anything on the screen?
It really does seem like it's automatically looking for a signal, but I really do not want it to. Oh, that's the menu.
Yeah, zoom in the time domain because it's going to mess with it. It doesn't have much memory. So first, just zoom in on time domain because it's having to display a lot of information and it might be capping kind of like an internal processor.
Okay, so now it's in 200 microseconds.
Okay, yeah, just let it sit there until it actually draws on the screen. And you're in auto. So click on auto, the auto button a couple of times.
Hold on. Where's it?
It seems it's right by the green button that's lit.
Oh,
it's because I should have taught you this. So, and on channel 1 and 2, you have to press the button in between the two big knobs in order to show it on the screen.
Channel 1 menu?
Yeah, just press it. It has to be pressed in order for it to show the actual signal. If you don't have it pressed, so then it's not showing the green channel until you press the one in between those two.
Okay, right, that does make sense. No, it's fine. That does make sense. If I now dim it, there's a lot of noise. There's a lot of noise, but it's not really.
What type of LED is that? And is that LED work?
Well, let's see. It does work.
Oh, interesting. And it's kind of like a blue. You might need that kind of same frequency blue light to shine on it.
In that case, let's try white.
It might be too low light.
Let's try a tiny white one then.
That might work better.
And you don't plug
Yeah,
them
you should.
backwards to measure, right?
It shouldn't matter. No, it should just go reverse polarity.
I think there's just too much noise.
Yeah. Huh. You don't have like a flashlight you can shine on it really close?
You know what's funny? I actually don't. I have an oscilloscope CNC machine and a 3D printed that arrives soon, but I do not have a flashlight.
Not even the flashlight on your phone?
Oh, I sometimes forget I have this thing. Fair point. Fair point.
If you put that really close, it should, because of the inverse square law and the type of light that you have. You should see a signal if you put a light source right next to it.
All right, it's in, and then. Oh! No,
It
I
should
think I
change
just
it. So
got
if you
the
zoom out,
cables.
it's gonna oscillate because every LED does pulse width modulation. So you're actually gonna see the pulse width modulation from the emitting LED on it.
There is a
Then
wave.
yeah.
I
But if
know.
you get closer to it, it should increase the height. But
Let me just dim out the noise.
that's weird that it's not working that well. Huh. Now you got me curious.
Troubleshooting a alternative usage of an LED.
Well, and I don't have any LEDs handy, but that's how I measured the speed of light because I shined a laser at an LED and it definitely shows a giant signal.
This is incredible. I mean, so from now on, whenever I want to measure a signal, I know how to do it.
Yeah. And you can calculate cool science stuff.
I think well, most likely I will just use it genuinely for standards and connecting stuff, because just imagine how many hours I could have saved with the UART if I just measured it with an oscilloscope and stuff. It feels wild in retrospect. With basically what I was doing is I had just two blind guys trying to walk towards each other. That's basically what I had.
Yeah.
No other information. It will probably get me quite a long time till I actually manage to. Oh, they get pretty hot, don't they?
No, they shouldn't get hot.
Well, that's not good.
What's it connected to?
Unless it's just the oscilloscope that got hot, because it is quite hot.
Oh yeah, it's probably processing a lot.
Yeah,
there's probably a fan on the back. You might not want to keep it in that orientation for too long. I'm not sure if there's a.
I probably shouldn't keep it on its power cable in general. Let me put it on the side. Let me to respect.
That thing is cool, man. That's a good oscilloscope.
I'm really glad I didn't go for something cheap. Only I decided to go for a proper oscilloscope.
Yeah, 150 megahertz. That's
1 gigasample, 200. Oh, because the low ones are for just generator, right? That makes sense. Wave generator. I don't know if I'm going to use the wave generator much. I don't know how. I don't know what it does exactly. It's just used to generate a wave.
Yeah, so I mean, you could generate a clock. So is it an adjustable generator?
I don't see a knob for it, so I do not know.
Yeah, it usually just generates a signal so that way you can adjust your probe on your oscilloscope. That's the only thing I use that signal generator for. But there's standalone signal generators that a lot of hardware hackers use to like send a proper clock signal or to like overclock,
Wouldn't
literally
w-
increase the clock signal.
wouldn't signal generator just be like a Raspberry or an ESP? Wouldn't that work?
Yeah, well, any microcontroller with a DAC, yes.
Yeah, I imagine like an ESP would be a bit easier to wield as a signal generator.
Yeah, but it's low resolution. So if,
I suppose
let's
that's fair.
say you needed, yeah, signal generator is the only thing I know that you use for is like making a clock signal. Literally.
I need to somehow store these probes because the way that keeps them safe. I'm really worried about
Yeah.
damaging this one. It's kind of important.
I put mine in like Ziploc bags
Yeah, that's probably how I store mine as well.
just so that way they're separate. And what's also cool about that probe is it comes with little plastic rings. And the reason why they have those plastic rings is you can change the color of the plastic on the probe so that way it matches the color on the oscilloscope.
Also, this.
Yeah. So if you could put the yellow one on it or the green one. There should be a green and yellow one.
I don't mean to be that guy, but there is blue, purple, red, green. There isn't a yellow. There is a yellow
It's
cup.
already on the probe. The probe is yellow.
Oh, I'm an
See
idiot.
Yeah. So but if you had a different probe, let's say with a different color, you could actually then put that little plastic on it. See, that way you'd know which is which.
Right, that does make sense. Okay.
You now know everything about oscilloscopes that I know. Make it. It didn't take that long.
I mean, yeah, it
You have
feels like
surpassed my knowledge now.
it feels like it would be more of a practical kind of thing than theoretical. I'd say.
Yeah.
Because most of the information is not something you can actually think of at the top of your head. Most of the information about anything practical is just things that you realize you know once you're doing things. I don't know if I'm making
Yeah.
any sense. Like,
No, that makes sense. Like I couldn't tell you all of the capabilities of the oscilloscope, but if I needed to fix a certain problem, I'd probably come across it and use an oscilloscope to fix.
yeah, exactly. Or if,
Come up with, do XYZ and this will happen.
or well, or even like a classical example, like with ESP, the best one. There was this pin on the ESP, wasn't there? That was interfering with.
18, yeah.
Exactly. Like off the top of your head, if you're teaching someone how to use an ESP, you probably would mention it. But if somewhere down the line you're working on a project and then you get an interference on the pin, or even worse, like some kind of pin isn't sending data properly, then you would know that it's interference because of that reason. Whilst the person who is new to it probably wouldn't. So I imagine
Speaking of which, I actually didn't even know this. It's all if there's two types of ADCs on a ESP32, like channel 1 and channel 2 is always used to generate the Wi-Fi signal. So all of the ADC 2 channel pins, there could be multiples. Those, when you're sending Wi-Fi, will be garbage. So it turns out it's not just that one pin. It's all ADC channel 2 pins on an ESP32.
curious on here. There is a USB connection.
Yeah, the USB on the front, you can put a flash drive, and it usually saves the waveform that you recorded on the screen.
That is quite convenient.
Ooh, and that looks like a USB Type B. Maybe you can actually, yours is a newer model. You might be able to view the data through the PC somehow. That's super cool.
I'll have to look into it later on. Because my first.
I don't think mine has that. Never mind, mine has it.
The tone was just great.
If I recall, there's some crazy driver you have to install on your computer that's suspect.
I was about to say that I probably need to check out the drivers for it later.
I don't use it. I tried back in the day and it was it doesn't do anything. They actually sell one that's just for your PC that I might buy in the future, but
There is one last mystery I'd like to solve, and that is the mystery chip I just found. Actually, a module, sorry. Well, it has a chip on it. ITG MPU.
chip on its shoulder.
Chip on it, yeah, it has a bit of a chip on its shoulder. It's very, I trust it. HW123 ITG MPU. These are the only things I can find on it. Oh, well, that is exactly it. Breakout board for the MPU 6050 MEMS, micro electromechanical systems that features a 3-axis gyro. It's a gyroscope.
Yeah.
Why do I
That's
have
awesome.
that?
Because they're awesome.
Yeah, I mean, fine. Yeah, I'll take it. Well,
It's a 6-axis gyroscope. I'm actually using some of those in my projects.
probably add it to the mask. I like the idea of knowing which way I'm facing. just
Yeah.
having that data for some reason.
So 6-axis are usually accelerometers, and then for 3-axis, and then for 9-axis they have 3 for the magnetometer. I can't remember what the other 3 are.
I should put it down. I keep dropping things. I need to stop ruining good modules. Anyway, I think I'm going to go now. I still have a lot of work to do. It was really fun. I am just excited to start using my oscilloscope on just anything I can, probably. I'm just gonna keep finding random components and just keep plugging them in. But unfortunately I do have to go now because, well, I am way overdue with this video. To get it done.
Yeah. Thanks for having me on.
Thank you so much for your help. There we go, Irish exit. I'm not gonna lie, I am a bit upset that I have so many fun things now to play around with, but instead I'm just working on a Blender video. Oh, and my camera died. Well, what a perfect timing. But yeah, I do have to go now because the video will make itself. Thank you once again so much to Efta because it's been a huge help. And for now, that'll be it. Thank you everyone so much for watching and have a great day. Bye.